right, so this is going to be the Spectral Lines Lab, and Giovanna is going to take the measurements. So grab your spectroscope, Giovanna. This is a spectroscope, and you use it for seeing spectral lines of things like these bulbs. Okay, but to show her how to use it, I'm going to show her using the fluorescent bulb, which is up here. I have a little slit cut. So come over here. So now if you notice, there is a little opening, very small opening there, a tiny little slit. That is what needs to aim at the light source. Okay? And if you look inside the spectroscope, what you see is this. You see these little numbers on the top. So let's see if you can see. It's very small, 4, 5, 6, and 7. And the light has to be shining through that little opening, and you'll see little colors over here. So try it. You gotta stand just about right here. Hold it this way, and then aim it this up to your eye, and aim it directly, this part directly at that little opening. Go back and forth, left to right, until you can see it. When it's bright, you should see the colors off on the right-hand side. I think you're a little off. Can I turn you a little? Move
Right
this
here.
way, like that. Is that close? So you need this light to be shining right through this opening.
Oh wait, I found it.
You got it? So off on the right side, you see the colors?
Yeah.
Now can you see the numbers above it? Okay, do you see the numbers 4, 5, 6, and
yes,
7?
I do.
Now that 4 is 400, the 5 is 500. Okay, these are in nanometers, which are billionths of a meter, okay?
Okay.
So every little, do you see those tiny little notches in between, these tiny little ones?
Yeah.
Those are 10 nanometers, right? So what you can do is you can get the color that is below to the nearest 10 nanometers. You follow it straight up and see about where it lines up, all right? So do you see the green one?
Yeah.
What does that seem to line up with if you follow it up?
550.
550? Okay. So now that you know how to use the spectroscope, okay, we're going to go around, and why don't we actually, we'll start reading off those ones for Lucy, and then I'll shut that off. It'll be a lot darker, and then we're going to start looking at these. Now when you do these, let me just show you that the little slit, the little opening, has to line up with the bright part of the bulb. So you have to be kind of right above it looking down, and you might need to go left and right until it shines through there, and then the colors should be very distinct. Okay. And then you're going to try to read off the 4 brightest wavelengths. Like if you notice, you can sort of see what they are if you look through here. You can see, oh, see that red one and that blue one? You know you're going to get those. You try to find the 4 brightest that are the signature spectral lines for that element. This is hydrogen. But if you can't get 4, then 3 is enough. You can really do it with 3. And there'll be some of them that are tricky where there's a lot of colors, and you'll have to make a decision of which colors to record. Okay? You'll record the brightest parts. But what you don't want to do is just go from left to right and read off all of them. You want to basically give her the 4 most intense, vibrant colors. Okay? So then Lucy's going to record, and you're going to go around. Why don't we start with the fluorescent bulb and see what you get. Lucy will write them down, and then we'll go through these. Then I'll have to swap these out for the other 6. Okay, we'll do it a little later. Does that make sense?
Yeah.
Okay, you're excited about this? Yeah. Thumbs up, thumbs up. Okay. So this is what it looks like when you look through a spectroscope. And you can see that it's a little tricky to get all the numbers. It's hard to even see them through the camera because the lights are so much brighter. Okay, so by the way, this lab is being conducted by my daughters, Giovanna and Lucy. And Giovanna's taking the measurements. Lucy is recording, and she's going to record right here. We're doing the fluorescent bulb, this one. I put a fluorescent bulb in there, and she's going to try to get the 4 brightest. Giovanna's going to read off the numbers, the wavelength, and the color. Okay, let's go.
One second, I just need a position. So I have to get the brightest?
The brightest one.
The brightest one's, okay. I would say green at 540.
Okay, so now Lucy's going to record it. Good. That's the first measurement. And the unit is nanometers. Okay, so just write the unit a little smaller and the number bigger. We usually write units smaller and green. Good. Okay, what's the next one?
Okay, I'd say red at 6, like 10 or 20.
Okay, red 610. Now if I look at it like this, we can see what the brightest ones are from this. Yeah, but we don't get numbers, but you can see, yeah, there's a really bright red one, really bright green one.
620?
Yeah, 610 or 20. I don't know. I think it's closest to 620. Yeah.
What? Okay. Well, whatever her first thing was. Okay, good. Now I'm not, and is that red? That says red? Okay, so now I'm not going to be showing you everything that Lucy writes down here. I'm going to show you the first few so you can sort of see how she's recording it. And then you're going to be recording what she reads off later. So make sure to write down everything. These are correct. She's going to get 2 more. And then we're going to start way up on hydrogen. Okay, what's the next one, Giovanna?
Oh, definitely blue. At 440.
Yeah.
Okay, 440 blue. And the name of the color, I'm trying to talk quieter because I know I'm near the camera.
Yeah.
The name of the color isn't as important as the number. The number is the main thing. So as long as the color is approximately right, that's fine. Okay, and one more. Can you get one more? And then we're done with the fluorescent bulb.
Okay, this last one. Okay. It's either cyan or yellow.
Oh, you're getting all tricky with cyan. Wow.
I'll stop.
You can just use regular
I
colors.
don't.
Okay. Well, just whatever. What's the number?
I think it's yellow. I think yellow's the brightest at 580.
Okay. So now we've got the 4. So here's an example of how to record it. Now later, this data is going to be transferred onto another sheet. We're going to take them and we're going to transfer them on another sheet with just a little pencil line. Okay. But right now, this is just the raw data. So this little scratch, this is really scratch paper. I made it kind of fancy, but this is just recording our data, the raw data. Then later, we're going to put it onto the actual back of the lab in the right position. And that's a little more technical. I'll show you how to do that later. The next one we're going to do is hydrogen. Now we got to make it darker for hydrogen. So what I'm going to do, I'm going to shut the fluorescent bulb off and shut off, let's see, this light. Now turn on the hydrogen. And tell me if you can see the numbers in there, Giovanna, in the spectroscope. That's
Yeah, I can see them.
You can see the numbers? Okay.
Yeah.
So now you got to move back and forth, left to right. You want to get a little closer down. Get a little closer down. They'll be bigger. They'll be brighter. You want to get her, she's lining up the little opening on the spectroscope with the brightest part of the bulb.
So much easier to see the colors now.
Okay, yeah, some of these will be easy, some will be hard. So now Lucy's recording for hydrogen. Good. Okay, go. What's the brightest one? Doesn't matter which left to right, but which is the brightest, most vibrant.
Alright, red at 660.
And we can see, oh man, we can really see it right here. We can see it from this distance with this little diffraction grating. This diffraction grating does the same thing that a spectroscope does. It just doesn't have the numbers on it. So see that red one? That's what she's recording. What do you think the next one is, Giovanna?
Cyan? I don't know. What am I supposed to call it?
Okay.
What am I supposed to
I
call
thought I usually call that one like aqua. Am I wrong? I don't know. Whatever.
I've just gotten a habit.
What's the
of calling
difference
it
between-
cyan.
Okay, sure. Aqua, cyan.
I'm not gonna.
I'm not good at those fancy colors. I just know red and blue.
Like burgundy.
Red and blue. Those are the only colors. It's cool because we can see them on here. This is neat.
Blue. Yeah, that's blue. I don't care that you call it violet. It looks.
No. This one is blue. I can see it on this.
It's closer to violet this time.
Just give the number. Come on. Give the. Oh my gosh. Give her the number.
Blue at 440 or 450. 440.
Yeah, we can really see the colors. This is working great. So while you're reading them, we can see them on here, but just without numbers. So now try to get 2 more if possible.
Yeah, cyan is at 490.
Okay, so we're repeating that one just to make sure that we have it.
Yeah.
So you said cyan 490 and then blue
440.
440. Now this is probably the last one I'm going to show, and then you're going to make sure to write them down yourself. It's not showing up in the lighting. Okay, so this says 660 red, 440 blue, and 490 cyan. Now, if possible, try to get a fourth one, Giovanna, because ideally we'd get 4 for each. Even if it's not that bright, what is the fourth brightest one?
I'm not good at that.
No, you're doing fine.
Yeah, I mean, these three, like, if you could see this, oh my god, like, the aqua or cyan, that's, cyan, red, and blue are, like, really bright. Everything else is, like, very...
Oh, so you're going to say that there's no fourth one? Because it is okay to say that if you're sure that nothing else is...
Like,
if you can see anything that's distinct at all, but if not...
I mean, all the colors are just, like, the other colors are
The
just
spectrum?
as distinct,
Like
and
the
it's
rainbow?
hard to pick one.
Okay, fine. So you're going to call this one a 3. So then, Lucy, put a little dash there. Now, it is possible to do this. Just keep in mind, we're going to try to get 4 for all of them. But guess what? If we see that again, if we see one that we can't get 4 for, that has those 3 bright wavelengths, then we can match it, because that's what we're going to be doing. We're going to be trying to match some of these. Okay, so now we can shut off that bulb and go to the helium. Let's see what the helium looks like.
Jesus.
Ooh, oh, that looks great on this. That looks great on this. See that?
Oh, wow.
Okay, so read them off, Giovanna. Let's go faster now. I think the brightest one, okay, what color is the brightest one? I can see on here.
Yellow.
Definitely, right?
Yes.
I can see it. It's like right in front of your face. It's right in front of you. So cool.
What number?
That would be 590. That's the closest I can get.
590.
Yeah.
Okay.
So I'm just trying to position it right. And there's green at just like 510. Yeah.
Yeah, we can really see them there. Yeah, I see the green one. And that is very vibrant. You can really see these are very distinctive, right? This will probably be the easiest one, Giovanna. Sorry.
It's fine. This is better for me.
I know the other ones,
Really stressful otherwise.
you're going to get mad at me soon because some of them aren't this easy.
Oh no.
Okay, just keep going.
Probably like the last one.
I hate stress. Okay. Blue at 450.
Stress is better than strain. It's a geology joke.
I don't get it.
Well, you get stressed, which produces strain. Okay, whatever.
Focus. 4. One second. I need to look again. Thanks, Bryce.
I don't do this to my students in the labs, by the way.
My God.
450.
So how many is that? 3?
Yeah.
Okay, one more.
Oh, I wonder which one it could possibly be. Oh no.
What color?
Red.
Yeah, I see it on here. Those are so clear.
670. Definitely.
Oh, bam. Wow, you're getting very confident. Maybe too confident. Okay, switch it over. Now, here we go. What's this one called?
really
Read it off to Lucy. What is it?
Nitrogen.
Flip it on.
Wait. Is it
Flip it on.
this one?
Flip it on.
Okay.
Oh!
Jesus.
Is that going to be easy? Students, is that going to be easy for her? Can you tell already? Yes, it's going to
Probably
be
gonna get like harder.
so easy.
Oh my God.
Do you like rainbows, Giovanna? So this one is a trick. So here's the thing.
No.
Oh, come on. So now, when you get a situation like this, you got to make a decision about which parts you're going to record. Or you could say from this wavelength through this wavelength, or you could just tell me what the brightest parts are. I mean, I know that it's close to, it's not a full rainbow. I see a definite gap in there. But you could also describe where the gaps are. That's another way to do it. That's sort of where it's missing.
Well, so far I've seen 2. And,
Okay, so you can describe the brightest parts. Okay, so give her the brightest sections where it's the most vibrant.
I mean, obviously, red. I think red has been in all of them. Yeah.
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 And it's still red. Yeah. 610 to 680.
Oh, so it's a band. Okay,
Yeah,
good. So when we
610
record this,
680.
so when you record that, show me how you're recording that, Lucy.
Yeah, you put a dash.
Oh, good, like a dash. And I can't see this with the lighting. Let me just see that. Yeah, so that's a good idea. And then that'll be a little bit different when we record it on the data table. Okay, let's try to get these faster now that you know how to do it. And this is decisively a hard one. Usually I put a sticker on this one that says this one is tricky. So just do your best. Do your best.
I had trouble with that one though. This has been.
No. But that was getting the hang of it. Now you've got it.
Okay. Yellow at 580 to 590. So it's like,
Well, that's so small. Is it worth? Okay,
Nah,
that's fine. That's fine. That's fine. That's fine.
it is a small band though. It's like,
Okay.
I mean,
Keep going. What you're doing is fine. I've never seen anybody else do it like this, but that's
I
fine.
don't care.
Just kidding.
Oh
just,
my God.
just kidding.
Green at 520. You are stressing me out so much right now.
I don't do this to my. I don't do this to my students.
I
We're
hope
listening
not.
so loud.
No, I'm not.
520 to I just feel you watching it. To 560.
Not 565. I'm just kidding.
Stop.
I'm just messing with you. Keep going. No, you're really doing it well, Giovanna. This is good.
I'm trying.
This is about as good as a typical student does, which is why I'm using you guys for doing it, because you get to see what it's like to learn how to do it. Whereas if I did it,
I don't have chemistry class this year, so this counts.
no, I know, but when I was a chemistry student, this was one of
Oh
my
God, here we
favorite
go.
labs. This was one of my favorite labs. But at my school, we only had like one bulb. I'm not kidding. So we've got more bulbs. No, listen. We've got more bulbs than the Griffith Observatory.
I don't know how many bubbles I have.
Yeah, but if you go to the Griffith Observatory,
I've been there when I was like 5, but
they don't have this many bulbs. Trust me.
okay.
You bet. Okay, let's keep
Wait,
going.
they don't? How big is it?
Just keep going. What's the next? You get the last
How
one.
do you have this many bulbs? That's concerning. I don't know.
Because we've stocked them up over time.
Yellow? Wait, did I already see? We
Yeah, you already said yellow. We just went green.
Okay, purple. 420.
See, now what you call purple, like I would call blue. Interesting.
You really want to do this?
No.
Okay.
You're like, she's colorblind.
Good.
Okay, then we're gonna come over to neon next.
Finding out.
Okay, so what's the next one?
Okay, neon.
Did you know this is a noble gas? Did you know there's no such thing as neon green?
Red.
I mean, you've said that over like 20 times in my life, so I don't know. Maybe
That's
I-
the color of neon. Okay, so let's see what colors she's gonna get. Okay, let's go.
Looks like fire. I'm scared.
Well, fire does become plasma at some temperature.
Well, yeah.
Plasma, well, okay. Fire is very complicated, but this is plasma in the bulb. By the way, it's not gas anymore when it's conducting electricity.
Okay, I'm just gonna yellow at 580.
Do you like that one, yeah?
Okay, he has the grape in his mouth. I thought he was trying.
And if it's like nitrogen, if it has bands, you can read off the bands as well. Let's see what it has.
Orange at 610. Well, I mean the bands are like really small, so like
Yeah, that's
I'm
fine.
trying to condense them.
You make the call.
Unless
As long
they're
as
really like unless they're like at least 2 what? I don't know.
as long as you're consistent, it'll work.
I mean I'm trying.
I love how Ian's just watching. It's the light. It's rainbow on the side. Like, that's light. That's rainbow.
Yeah, because he has the diffraction grading glasses on, kind of like these guys have.
That's orange and that's rainbow.
Let's get these measurements a little faster.
Wow.
Let's go faster for the rest of them.
That's just rainbow.
Ian, please stop.
Okay, good.
Red at 650 to 680. 650 to 680.
So what I'm not showing anymore is what Lucy's writing down, so that students should be writing this down themselves. You could have copied down the ones I showed before, but for the remainder, it is awfully bright. Did I mention that some of the wavelengths it's releasing are ultraviolet?
Well, you can't see that.
Good, wow, good. Check
you
out
say that every single time there's a rainbow. You're like, do you know there's some ultraviolet there? You can't see
Do you know what ultraviolet means?
No, I don't.
Above violet. Do you know what infrared means? Below red.
How are we supposed to know that?
I mean, I would guess
from your Latin and Greek roots, Lucy, from your Latin roots. Ian.
Oh god, here we go. Fourth one. Oh, I did. Okay. Green at 540. Yeah.
So what's happening is the gas in the bulb is being converted into plasma in order to conduct electricity. It's producing its spectral lines and glowing. Okay. And is that all of them for that?
Yeah, we got.
Then I guess we can shut that one off. Now let's switch to the next one. What's the next one?
Argon. I've never seen.
How Argon? That's like you, Giovanna. That's the lazy element. Oh, just kidding.
What?
I mean, it is the lazy
I
element.
could say something, but I'm not.
Thanks. No, she's not lazy. Well, she may or may not be lazy. I won't say either way. Okay.
Thanks for keeping me.
So, did you know that the argon we're breathing, it's about 1% of what we're breathing right now? It's about 1% of the air. Did you know that?
No.
Yeah. So you're breathing argon, and argon is actually produced mostly from the radioactive decay of potassium. Does that freak you out? It's produced by radioactive decay. Anyway, so it always is replenished in the Earth's atmosphere by decaying rocks that have potassium in them. It's not just bananas. It's not just bananas that have potassium. Okay, it's actually rocks. Rocks. Okay, so let's get the wavelengths, and Lucy's gonna write them down.
Ready?
I would get closer.
Oh. Alright, so purple is at 430. Okay. I'm not gonna be that exact with the colors this time.
Okay,
I
great.
will in the future, but
Well, purple's almost a real color. Go.
okay. Red is at 660.
Let's see. Can we see these? Can we see these? Oh yeah. So you can see them on.
I mean, it's not as good as mine.
Not as yeah. It doesn't have the numbers, but it's basically you can sort of see what the bright ones are. Oh yeah, I see the purple and the red. Yep.
Green is at
Yep.
490.
Oh. Yep, I see the green. Let me guess what let me see what I think the fourth one's gonna
Alright, go
be.
ahead and take a guess.
Oh, it's hard to tell.
I know.
Oh, is it like orange?
Yeah, I was
Okay.
about to say that.
I see it on the bottom. I can see it more on the
Okay,
bottom.
so orange is 610. And that's that.
Wait, was that already all four?
That's all four.
Oh, that was much faster. Let's keep going that fast. Well, we're almost done. Okay, so let's shut that one off. Bye-bye, argon.
Bye-bye.
Noble gas. Oh, by the way, neon was a noble gas. Argon is a noble gas. Krypton is a noble gas. Krypton, you know that's where Superman was from? Or was that the star or was that the planet? I'm not sure. One of them blew up. Either the star blew up. Yeah, but it depends on which version. Like sometimes the star blows up, sometimes it's the planet. Well, it's where Superman is from. Krypton means
Wait, what?
hidden. Krypton means hidden. Let's
Wait,
see,
is it
see how
actually green though?
let's see how easy this one is. No, that's kryptonite.
Oh yeah, kryptonite, sorry.
And by the way, this does not form compounds, so there is no kryptonite. But sorry to burst your bubble.
I mean, I never really thought it would. Okay. That's like the least bright one. I don't know.
The least bright, yes. Okay, so just record it. Record it.
Correcting my grammar again. Oh, that is. I'm just gonna piss.
I could
Lime?
dim the light if that helps you see it better.
No, this is fine.
This is fine because you might be able to see as long as you can still see the numbers behind it. Can you still see the numbers? Okay.
I see. Lime.
Lime?
Lime. You're not gonna. It looks more of a lime than just the green.
What?
Okay. And
550.
the word krypton means hidden. Okay, so this was a hard one for chemists to isolate.
Why did the planet?
There's a very
Planet called that?
the planet
In super.
because it was a hidden planet.
Oh right. Sorry.
It's his,
I haven't
and then he has the
watched
Fortress of Solitude. Everything with Superman is super secret.
Yeah, but
And by the way, argon, there's a lot of argon in the air. You're breathing that right now. You're breathing argon. But
Is
there's
it really
very
a
little
secret if
krypton.
like over 1,000 people know about it? Like if you were to ask someone who Superman is,
Let's just get the
you're not
measurements.
about in their universe.
Let's just get these
Okay,
measurements
fine,
because this is
I'll
going to be
stop.
way too long.
Yeah, you're right. That is okay. Orange at 580.
Oh yeah, I see the orange one. There we
Yeah.
go.
That's actually a really distinct.
I bet I can say what the next color she's going to go. Oh, you already did the lime one. Oh yeah, it is kind of lime. I see what you mean.
Oh my God! Wait. This is, oh God, we were having a dispute whether it was blue or purple, but now it looks like there's a blue and a purple right next to each other, and this is freaking me
Well,
out.
which one is brighter? Oh, you got two more.
Yes, I know, exactly. So this is just, I don't know if I'm seeing things, and that's not, there's like,
Just come on.
okay, I'm just gonna list both of them then. Purple at 440, and then blue at 450.
Right next to each other. Interesting. Yeah, that happens a lot with like sort of like twinning, like twin spectral lines.
Yeah.
Okay, so what I'm gonna have to do is swap out all these bulbs. Let's shut that one off. Shut that one off. And then I'm gonna switch out the bulbs and we'll go through the other set, okay? Good job so far, guys. Good job. High five. High five. Okay, so now we're gonna go to the next one.
Oh, it's oxygen.
Oxygen.
Okay. Okay.
Isn't that pretty?
Yeah.
That's one of the reasons I make oxygen blue, even though the convention is to make it red. Isn't that weird? I make it blue on my models. That's one reason.
Yeah.
So let's see, what colors is she gonna pick out here?
I'm trying to get it lined up. Oh my God, it's
The
flickering.
bulb is loud. Oxygen bulbs don't last very long, so just get your measurements. They don't last long. We've had a bad experience with.
Green is 520. Quick, go. Oh God, I can't. Red is 600.
It's already getting faint, right? Yeah, oxygen bulbs, they react
Okay. I'm sorry.
and keep going.
Blue is 450.
Wow, very decisive. Good.
Okay, next.
Yellow is 550.
Oh yeah, I can see the
Okay,
yellow
we
one.
got it. We got it. We got it.
Is that all four?
Yes.
Oh, you did?
Yes.
Oh, great. Yeah, oxygen bulbs, we've had a bad experience. Oxygen bulbs and water bulbs.
You told me that before. Jeez, you're trying to.
It's okay. No, I'm not trying-
Now.
Okay. No, I'm just oxygen bulbs, we've had a lot of them burn out. They don't last as long as the other bulbs because oxygen is a very reactive element, and I guess it reacts with the cathode. I'm not sure.
Other of these like that.
We already did the other one. Okay, go.
Okay.
I didn't tell you. I didn't want to stress you out. Okay, go.
Oh,
Ooh, what's this one? Oh, boom.
Mercury. Oh, wait.
Daddy, isn't this poisonous? No, Giovanna. I mean, yes, Giovanna.
Seriously?
Well, not if it's in a bulb.
Jeez. That's very
Come on. Oh, I can see what colors they are, right?
lime. It's 550.
I see. Yeah, it totally looks lime on here. I
See what I'm talking
100% agree. 100% agree.
Thank you. Jeez.
For once.
Not you ruined it. Okay. Purple is 450.
Okay.
Yeah, or blue, or whatever.
Can you stop?
I wonder if things just look different on a camera. Okay.
Yeah, I wonder. That's an old. Orange. One second, I'm trying to get this. 580.
Do you know the old name for Mercury in English? Quicksilver. Like the X-Men. Isn't that one of your favorite scenes in X-Men?
Yes.
Oh, it's yours?
It's awesome.
Everybody, it's
She
every.
copies me on
Oh, but it's everybody's
I
favorite.
know, but the only reason she knows about it is
But I didn't like his scene in Age of Ultron as much. He was also in Avengers.
that was the best scene though.
No, the X-Men Quicksilver is way better.
Oh yeah.
But I wonder what they're going to do now.
He's dead.
Well, let's not talk about X-Men. Let's get the measurements.
Yeah.
Oh, red is at 700.
Do you know why they called the element mercury? Most people don't get this.
Why?
It's because it's fast. Like it flows away. It's the only metal that flows. By the way, this is a
Oh
wait.
my
Wait.
God!
By the way, did you know this is a metal? You're looking at a vapor of a metal, which is.
I just realized what this is.
Yeah.
I just remember seeing. Oh.
They use it. They use it in some thermometers. Just keep going.
What?
Oh wow. That's an interesting color.
It's beautiful.
That's cool.
Some would say beautiful.
I mean, yeah, I would say so.
Vulcans would say interesting. What would Romulans say? Okay, go. Let's try to do these faster, okay?
You bring up start. Red is at 650 or 660.
Well, just whatever your reading is. Read off what you see.
Yeah, I
baby.
know, but
Okay.
I'm shaking it, and that's like.
Okay, yeah. If you go left and right, it varies about 10 nanometers either way.
Okay. Teal. 90. I don't know why it's so funny.
Has there been any element that did not have teal so far?
Cyan, Bryce.
Oh man.
Great. I love this.
Oh my god.
Oh, it's flickering out. Wait, we need one more. Two more, actually. God. Oh,
I can see what they're gonna
Bryce, is that a blue or a purple? Tell me, please.
On your- Trust me, on the camera it looks blue, but you decide.
Oh, but then you were disagreeing with me all the other times. Tell me, please, if you want.
No, come on, let's do this
Oh my
faster,
God,
please.
I don't know. Okay, purple is 440. Okay, I can't. No, there's no fourth one.
No fourth one?
No.
Well, you can put a dash. Okay, then let's come over to.
Like, there probably is, but it is so hard to see it. I can't tell.
So what?
Okay.
So what's this one?
Unknown. That's great, Bryce. That's.
I already saw.
This is an unknown because you know what we're gonna do? We're gonna match it. This is part of the lab. Okay, so don't worry, it's an unknown. Just record it just like any other one. Just like any other one.
I've never seen this one.
Well, why would you have? It's an unknown.
No, I know, but you showed Lucy apparently before. Oh no.
Yeah, I just looked.
Oh yeah, Lucy knows all the answers. Don't tell her, Lucy. Don't tell her the secret. Okay. Get the brightest one first.
Yellow.
Yeah, I can totally see that.
Okay. Yellow at 590.
Wait, isn't there a fancy name for that shade of yellow?
Oh my god.
Gold.
Yes. Oh my gosh, it is gold.
There. Putting.
Stay gold. Stay gold, pony boy. Stay gold. Stay gold.
I already put yellow.
Have you ever seen The Outsiders?
Yeah.
What? You
Yes. In 7th grade.
I have
Oh.
it.
My English teacher was great.
did? Oh yeah.
I have it.
That's such a good book. Oh my god. It is one of the ones I actually enjoy.
Okay, let's get the other measurements.
Nah, I'm gonna call it teal.
At what?
Oh my. Isn't teal a bird?
No.
Isn't it a bird?
No.
I bet it's a bird. Watch, I'm gonna look this up.
I think you're confused.
I think it's a bird.
think
Okay,
it's
whatever. It's a green bird. Whatever, just go.
I don't think so.
Maybe not. We'll see.
Why do you think it's a bird?
Because there's a bird called a teal. Whatever, just go.
There is.
Oh, okay. He's just trying to. Okay, teal is at 500.
Okay. Roman numeral D. Okay, keep going.
Okay. Red is at 670.
Those are pretty colors. Look, they come out really
Yeah,
well.
but then take it off and just look at it.
Yeah, and even that's pretty.
Okay.
These are mighty pretty bulbs.
Oh my god.
I mean, I
Unknown.
would
What
say
is
that.
it? What is the unknown? Giovanna, what is the unknown? No, don't answer. It's rhetorical.
How would I know this?
Because this is what. Okay, whatever. Let's go to the next one. It's a matching.
Me to know.
Oh, did you get all four?
Did we?
Yeah.
No, there's.
No, last one.
Wait, so what did we?
What is your favorite color?
We did yellow,
Okay, that's.
teal, and
I don't.
Teal.
Stop! No, that was cyan. You got that wrong. I'm kidding.
Blue. No, purple. Ah.
No, it's blue, no green. You got the quote wrong, Bryce. I'm pretty sure that's right.
No, it wasn't a quote. I'm talking about how we're mixing up blue and purple.
Okay.
Monty Python.
What's your language?
I didn't. Okay.
One more?
Blue is 450 to 470. Yeah, it's like two strips. It's like one here and then.
Okay. Oh, you mean it's
I'm
like
just going with that.
it's like doubled up? Okay.
Yeah.
All right, switch that off. Now the last two, these are extras. Now Lucy's just going to record them in this blank space at the bottom. She's going to write the name of the element. She's going to record 4 measurements. So we've got 2 extras that we sometimes use in the lab. Okay? What's the next one?
Xenon.
Xenon, and that means the strange element.
Oh,
It's the stranger or the foreign elements.
That's cool.
No,
Isn't it weird?
Yeah,
I
So
like
let's
that.
see if we can see
That
them on
color's
her.
cool. Yeah. This is my new favorite color.
Oh, really?
I mean,
How would you describe this color?
I don't know. I just know the specific one.
Do you know what I would say? Blue.
Very fancy.
Very blue. Just go, get the measurements. Oh my. This bulb is not as bright as some of the other bulbs, so.
Let me check again. Green is at 490. Yeah.
Okay, what's the next one?
It was so hard to see. Okay. Blue is at 470. Red is 620.
Yeah, if I look off on the side here, I see a blue, green, and a red one.
It
But
is
is
so-
that all you see? Is that all you get?
I mean, yeah, like it's very hard.
Okay, well this one's an extra one. Let's move on to the last one, the very last one.
We didn't do all 4.
Yeah, we only have 3, so put a dash there. Okay, and then the last one is, what is it? Iodine. Okay, turn it on.
Okay.
Interesting.
It's
Okay.
like a purple outline.
Oh, look at those. Wow.
Oh wow.
Okay, so you should have, just pick the 4 brightest. It has a lot of colors. Pick the 4 brightest. Isn't it funny how all of those can combine to make a color that's kind of like purplish? And then just like 1 or 2 can combine to make a color that is bluish. So you can't always tell from the overall color what the spectral lines are going to be. That's just how they combine. Okay, what do you get?
Wait, Lucy, get this down, okay?
Yeah.
Orange is at 590. Purple is at 440. And there's no, I'm not gonna.
Okay.
I see cyan. Okay, lime is at 510 to 540.
See, we agree about the lime. I see the lime again.
Yeah.
Okay.
Oh, it's starting to flicker.
Yeah, some of these bulbs.
Alright, so wait, Lucy, do you need one more?
Wait.
Giovanna, this is the only iodine bulb we have. A lot of the other ones we have backups. This is the only one we have. You better get your measurements.
Alright.
It is.
Oh, I thought you were joking.
No, it is, but I'm just trying to stress you out. Okay.
Well, now I know you're trying to, so it's not gonna work.
I think it did work. Okay, go.
Okay, blue. Did I say blue before?
No, you didn't.
Okay. That's at 450. Yeah, 450.
So, that is, can you shut it off? Thanks for all your measurements, Giovanna. Good job. And like everybody, you know, the spectroscope is plus or minus 10 nanometers, and everybody makes experimental errors, but I think you did a good job. Thank you very much. And then Lucy, thanks for your recordings. We're not showing all her recordings because we want students to have written them all down, but it's nice that we needed somebody to record all them. And now that's all of our samples. So what we're gonna try to do is match the unknown. The unknown, by the way, did you guys know this? Is the same as one of the other ones we saw. And not only that, wait, but so is deuterium. Deuterium is also an unknown, but I didn't call it an unknown. So there's actually 2 unknowns. There's actually 2 different unknowns that we're identifying in this lab. So we're matching them up. I'll show you in a minute how to transfer the data to the back of your sheet so that you can identify the unknowns. That'll be the next step. Okay, so the next thing will be transferring the data, but I decided to reformat the lab after we had done this. So here's the front page of the lab. You'll notice now that on the second page, it looks a lot like the one that Lucy used. I'm not going to show you all her data because I want to make sure you record it yourself. So this is where you record your raw data. See how we have, here's the one for the fluorescent bulb. I have that one. The other one's covered up. So you can see the four different wavelengths and the colors we recorded. Okay, so I'm going to show you how to transfer those. You got to make sure to transfer them to the same row, to row 11, fluorescent bulb. Make sure to match up. Okay, so remember that every element has its own signature wavelengths, and we're going to see those on here. It's better if you do it in color. With pencils, it works out best. Or if you need to use crayons, you can do it with black lines, but it's just not as obvious. It's much better if they're in color. And, you know, these are the colors that she reported them to be. It just has to be something like that. Like, obviously, I don't have all the colors in the world there. Like, she was giving me all those interesting colors. I'm just going to do something that's close. And so that's not that important, okay? And remember that the spectroscope has a little diffraction grating here. It works like a prism, that little, if you can see it there, that little shiny surface there, which works just like one of these guys, okay, which makes every light look like a little rainbow, right? And because these only have certain wavelengths, we only see them separated. And the great thing about the spectroscope is that if you look inside it, you can actually measure. Yeah, you can just see the numbers in there, huh? See the numbers in there. See that? Those are those tiny numbers she was reading. Okay, the other thing I did was I added xenon and iodine to the bottom. On hers, she just wrote them down. She just wrote them in on the bottom, but now I have it on the sheet. And I even put it here so you can transfer it. Okay, so just treat those in the same way. So because we use the xenon and the iodine, okay. All right, so I'm going to show you how to transfer now. So this is like the one that she recorded the data on. So it's better if you record your data on this one, the raw data. And this is exactly how you should transfer it, okay? And again, you could start with number 1, but I'm just not showing that because I want you to record that yourself. I'm going to just show number 11 as an example. Okay, so I see green, 540 nanometers green. So what I'm going to do is I'm going to get a green, right? And I'm going to look on row 11, and I'm going to try to find, well, this line is 550, so I'm going to follow that down. That line is 550, right? And 540, where would that be? Well, these boxes, let me just hold this 550 position right here. These boxes are 50 nanometers wide, right? So that means 25 would be there, right? And so if there's 10, 20, 30, it would be about here. You have to approximate some of these. So I'm going to put it right there. That would be 540 nanometers. Now, what you want to do is make sure to make it a bold line. Don't make it just a little streak. Make sure that it's visible. But don't make it too wide. Okay, just make it solid like that. Notice how I did that on fluorescent bulb. So that's the first one. And notice how it lines up right about 540. So 550 is this line. 500 is this line. Get it? And this is the range of visible light. Now what I want to do is cross this out on my data sheet. Just cross that out because we've recorded that one. So eventually you'll have them all crossed out. You'll be sure that you have the data on here. This is an easier way to see the data. This is the raw data. Get it? The next one is 620 nanometers red. So I'm going to get my red pencil, 620 nanometers red. Make sure I'm in the right column. 600 is this one. 650 is this one. 625 is the very middle. So just slightly to the left of the middle there. Just right about there. Just a little bit to the left of the middle. And that is my 620 nanometers red. Cross that one out. 440 nanometers blue. So I'm just going to base it on the colors that she gave me. I have a blue. Okay, it doesn't matter if it's exactly the same shade of blue that she saw. 440. Okay, so this line is 450. Follow it down. And again, it would be just a little bit over to this side, to the left of the I made that one a little thick, but that's okay. So that's the 440 nanometers blue. I'm going to cross that out. Notice I only have one more piece of data, and it has it as yellow, 580 nanometers yellow. Oh yeah, I've got a yellow. Let's do that. And 580 nanometers yellow. So I look down. There's 550. There's 600. I follow it down in between. So if that's 550, then 575 would be right in the middle. 580 would be just a little bit over from that. Now I got to make this one bold enough to see. Oh, you can see it on there. And those are the four spectral wavelengths, the 4 brightest ones, cross it out here for the fluorescent bulb. So now I'm done with, I could even cross out the whole fluorescent bulb now. And then you wouldn't have these covered up. You would go through the rest of your data. And these little gray ones, that's just the separation. And then you're going to put in all the spectral lines, all the ones that were recorded. Now remember, for some of them, we only had 3. So then all you're going to be able to put are 3. And then for most of them, we had 4. And then the tricky thing is at the bottom, it says to what element on the periodic table is deuterium. I don't really want you to look at the periodic table. What I want you to do is follow the lines for deuterium. Once you've put them in, just like this, you'll have them in, and then you'll follow them all up, maybe use your fingers, follow them up and down, and look and see what deuterium matches. Because deuterium is the same as one of these others. It's the same thing. So in other words, you're going to tell me which element it matches the best. If all 4 lines match, that is ideal. Then you could say how many of your spectral line data match. You could say 4. Or if it's only 3 of them match, or you could say, well, 3 of them match exactly, one of them matches kind of close, something like that, right? And then the other thing is the unknown. Well, obviously that's an unknown. You do the same thing. We got to match it. So when it says which element on the periodic table, what I mean is you're going to give me the name of the element, but it will definitely be one of these other than deuterium and unknown, 9 and 10. Those are our unknowns. There's actually 2. They're both unknowns. And you're going to match them up by going up and down. And that's the answer to this very important question. Very important question. And then, of course, there were the questions that were on the first page. Now, a lot of these you're going to be doing after answering that, after putting in all this data. And once you've transferred all your data, okay, then you can make sure it's nice and clean and you didn't miss any, okay? Then it's easy to compare them. You say, oh, that looks like that. And if it's exactly like that, boom, that's what it is. But you're going to have to pick one, whatever the best match is. Now, every experiment with these spectroscopes, they're plus or minus 10 nanometers. So just realize, give it a little wiggle room. Because if you move this slightly to the left and the right, the spectral lines will shift slightly. And so her recordings may be off a slight bit, okay? Other than just the way we recorded them and other things like that can come into it. So don't always expect it to be exact, but you got to identify the unknowns. And then there's another thing on here where you are going to find the energy contained in the 3 wavelengths of hydrogen. Just pick 3 of them. I think she only had 3, but only pick 3. So you're going to pick one that is the furthest to the left, one that is the furthest to the right, and one of them that's in the middle. And you're going to figure out how much energy is contained using these equations, okay? Using the equation E equals HF, okay? And you actually need to combine it with this equation. So I show that in the notes. So remember that we are looking at the spectral lines, the signature of an element. And by the way, spectral lines, the word actually means ghostly lines. If you look up the origin of the word spectrum and the origin of the word spectral, it's talking about ghosts. So this is really a spectroscope is basically a ghost viewer, if you think about it. Now, it doesn't mean literally. It means that the spectral lines, okay, when you see them, okay, they look kind of transparent like a rainbow. See how they're like kind of ghostly? That's what they mean. Okay, so good luck on finishing the Spectral Lines Lab. We had a little bit of fun making it. Maybe too much fun. Maybe too much.